This familiar phrase refers to salt's essential goodness, but as those of us with hypertension know, too much salt can be a bad thing. Today I'm going to describe the increasing saltiness of water resources in the Chicago region. Salt is the most important mineral in human history. It's been used for millennia for preserving and seasoning food, for medicine. It's also good for the brain. As you probably are well aware, it was so valuable that the Latin root for our word salary means salt. We still use a lot of salt today, over 240 million tons per year in the world, and there's probably more than 14,000 uses of salt. Major ones include water softening, agriculture, the chemical industry, and of course food. Another big one is a road de-icing agent. 15 to 20 million tons of salt are applied to roads, parking lots, and sideways in the U.S. every winter. In Illinois, this means the Chicago region, where most of the roads and people and a lot of the snow are. So what makes salt a good de-icing agent? Well, it lowers the freezing point of ice. This road salt has been used extensively since the 1950s, increasing rapidly in recent decades, although it looks like we may be leveling off in recent years. Part of its effectiveness has to do with its high solubility. A fully saturated salt solution has chloride and sodium concentrations more than 10 times the level that we find in seawater. This high solubility means that salt is invariably going to wind up in our water resources. And this includes all components of the hydrologic cycle: soil water, streams, lakes, shallow groundwater. Chloride is a conservative ion, so it moves unimpeded with the water, but sodium can absorb or exchange with other cations. There are numerous sources of salt that can enter our water resources. In the snow belt of the United States, Chicago, and Canada, including Chicago, road salt runoff is the major source. Melting snow and ice can inject lots of salt into our water, groundwater and surface waters. While sodium and chloride are not toxic to humans, chloride does have a secondary drinking water standard, and sodium has a health advisory. Chloride is also a major corrosive of most metals, including stainless steel. Excess salt levels can also be ecologically destructive. Salt spray can cause plant damage. Salt in soils can reduce biodiversity, only allowing salt-tolerant species to survive. And high levels of salt in water can be toxic to certain aquatic species. Road salt runoff can produce very high levels of chloride in shallow groundwater. Here are some monitoring wells in the Lake Calumet region of South Chicago showing chloride levels along I-94 of 2,000, 3,000, even 4,000 milligrams per liter. High chloride levels are found in stormwater in the Chicago region in the winter, but most of Chicago's stormwater enters the combined sewer system and thus does not recharge groundwater. So most of Chicago's road salt runoff actually goes through the water treatment process where it's relatively unaffected. So every winter there's a large slug of salt that comes out of waterways in the Chicago region, the size of which is a reflection of how snowy that particular winter was. Elevated levels are found throughout the year, however, and indicating that there's sources of salt other than just the direct runoff of road salt. Monitoring stations in Chicago Waterways indicate that chloride levels are increasing in many of them. These are stations monitored by the ISWS and the Water Reclamation District. We did a mass balance on the Des Plaines River watershed, and we estimated that about 14% of road salt is retained in the watershed every year. This remains in relatively long-term storage, which means groundwater. So we would expect to see increasing chloride concentrations in Baseflow, which we do. This is the Fox River showing concentrations of chloride after samples collected in September when we wouldn't expect any road salt runoff to be occurring, and you can see the increasing levels well above background concentrations. Salt is increasing not just in the shallow groundwater, but also in shallow aquifers. Here's some chloride data from public water supply wells in Kane County, steadily increasing concentrations since the 1960s and 70s in most of these public water supply wells. So we need to be smarter about our de-icing policies. Is bare pavement always necessary? Can we modify our application rates in ecologically sensitive areas? Application of brine before snowstorms is one method for decreasing the amount of road salt that's applied. There are alternatives to sodium chloride for de-icing, but it's by far the largest amount used because it's so cheap. Other chloride salts don't provide any environmental benefit, and the acetate materials which do are very expensive. Basically, all road salt that we apply is going to end up in our water resources, and the question is where. This is a problem that's going to be with us for a long time, and we are going to have to make some decisions that are juggling various interests, including drinking water quality, public safety, economics, and the environment. And I thank you.